The first thing in terms of our glaze testing is that we want to be thorough in our record keeping. So I, gave you that handout in class last week, and at the bottom there were these little charts so you could fill in the glaze recipes that you had looked up or that you were going to research and look up. And when I say be thorough in your record keeping, that's thinking about developing some kind of system so you can keep your glaze research organized, and so you're able to kind of look through, find, if there's a recipe that you found a year ago and you want to look that up again, you want to be able to easily access it. So think of some system. I've found that over the years I've just been writing things in different notebooks, and so they get all spread out everywhere. So I've been trying recently to try to organize it all like on Google Drive, where I can kind of search for things and find them. I have a document here. You can see I've been working on making, using glaze as kind of a sculptural material where I'm putting like large amounts of glaze onto a sculpture and melting it on there so it becomes kind of part of the form. So I've been doing a lot of different tests with that. And so I created a document for that one glaze recipe. It's really basic recipe right here. It has frit, which is a glass that's been pulverized into a powder, and there's a lot of different types of frits that melt at different temperatures. And then it has graulig, and graulig is a type of porcelain clay, a type of kaolin. And it's just those two amounts where we've got this in a 100% format here. And I also have right below it the chemical breakdown of those materials. All the different like individual elements of a glaze recipe or a clay recipe, these different elements like graulig, they're made up of these different basic chemicals here. And so if we look at graulig kaolin, it has manganese and calcium and sodium and potassium, alumina, iron, silica, tin. So it has all those different things in that one ingredient. And then we look at our frit, it also has calcium and sodium and potassium and alumina. And so I've like used a program like in Glaze, which is a website that I showed you that's on that handout. And you can type in different materials and it'll give you the chemical breakdown of them. So you can start to get a sense of like what different things are in them. So this is just showing you ways to organize your thoughts. I have been taking notes on its compatibility, like how well it works with different clay bodies. OCAC Super, which is a stoneware we had, I have pieces that I made a year ago and they're still making tinging sounds, which means the glaze is crazing or cracking on it. So I'm just taking note of that. But then what I've been doing is doing color tests. So I'm adding different colors to that glaze. And then when I get the glaze test out, I take a photograph of it and I write down what mason stain I used and the percentage that I put of that colorant that I put in. And then I add a picture to it. So I've found that this, just using like a Google Doc and putting a graph in there, has been a really good way for me to keep track because I can put the photographs in, which is a really helpful aspect. I have some of those color tests right here, and I write on the back what colorant I used and how much. This is 1% of mulberry stain. And so keeping track and writing on your tests is really important. I also have a glaze test tile here, and written on there is the cone that it was fired to and the glaze that it was. And then in my notes, I would take close observation. So the second thing on there is making thorough close observations. So thinking about like, how do we describe this texture, right? I wouldn't call this a smooth glaze. I would call it a like beaded or crawling glaze that is glossy, but shows like the clay or slip underneath. You can see that where I have white slip behind, the spaces between the glaze beads are a little bit lighter, than on the red part of the clay. And so there's a lot of different information here that I can record and take note of. It seems to be a really good, what we call glaze fit, like it's sticking to the surface. Those little beads aren't popping off at all. So those are all different things that we want to like take note of when we're recording information. You know, I have like all these different colored tests and they're all documented. I'm writing on the back of them all the information. So you'll do that with your glaze test where you'll write on the test tile itself in your notebook or in your Google document that you create. So going back here, you know, closely observe your fired results. And so when you're looking closely at the glaze tests and stuff, you know, be recording what you're observing and come up with some descriptors like to talk about the color, the surface, the way that the glaze works with the clay that you're using, things like that. A really important thing is to keep an open mind. So often when we are testing glazes, we might have a specific outcome in mind. We want a glaze that is glossy and is like iridescent and perfect for what we want to do. But oftentimes, as you guys probably know with ceramics, things don't turn out the way that you want them all the time. And so it's really important to keep an open mind in terms of thinking about what actually did happen. What are you looking at now, divorced from your expectations? And there, you might find that there are some exciting discoveries or something that you could use down the line for a different project. And so be open to whatever the results are, and don't be super stuck on having a really defined destination for your testing. And be playful. So if you have an idea of like, well, what if I mix this with this and dip a test tile in it? See what happens. Before we start firing our tests, we're going to also make trays out of clay. We'll just make a slab and like pinch up the edges. And that's what we're going to fire all of our tests in. So if we melt something too much, it'll be safe and saved in that tray, and it won't damage the kiln shelf. So we're going to set up some systems to allow us to be really experimental and play around, but also not like damage our equipment and things like that. So develop a quick way of testing. So that's what I am showing you guys with this assignment, is kind of a quick way to test and develop your own glaze interest. And this thing of like glaze testing is a like never ending rabbit hole. And so we'll start, you know, right at the surface, and hopefully by the end of the semester, you'll feel confident to kind of like develop your own way of like testing and developing glazes that works for you in your practice. So here, I just want to talk about what the heck is glaze, and like on like more of a chemical and physical sense. Like we know that we probably understand that glaze is like a surface or a skin that we're adding to our ceramic forms. When we fire our bisqueware that has glaze on it, the clay itself starts to melt a little bit in the kiln, and the glaze melts even more, and they bind together. It sits on the surface, but there's actually an interface between the glaze and the clay where they kind of melt together, and that's what allows it to like become part of the ceramic piece and fuse onto it. The cool thing about clay and glaze is they're essentially made of the same ingredients. They're just different ratios of these different ingredients. You can make things that live kind of in between the clay and glaze realm by just kind of changing the components of the recipe. So if we look here at what we call the theoretical formula for clay, so this is like in the vacuum of space where we're thinking about like what are the essential things we need to have clay. And what those things are is just 3 items here, which is alumina and silica and oxygen. And those things together create the like theoretical formula for clay. But we also, to have clay that we can work with and use, we add water to it, right? So we have this plastic clay that can be malleable and worked. Now, most clays, though, like clays that we use, are more complicated than that. They have a number of other things in them that do certain things that allow us to fire them in the kilns that we have in terms of how hot those kilns get, and melt the right way or have a certain texture or plasticity, things like that. So most clays also contain what are called feldspathic materials, which allow the clay to vitrify when fired. So there's some vocab in there that we'll talk about. So feldspathic materials are essentially rocks that contain alumina and silica, but they also have other fluxing oxides. So other things that help those different elements melt together. And so feldspar is like a general category for these materials that we mine, that we go out into the world and dig holes and find like areas of rock. They have a varying degree of different elements in them. And some of those are alumina and silica, which are our basic things that we need for our clay. But then they also have other minerals in them that would help the alumina and silica melt together. And so where it says allow the clay to vitrify, the flux is what helps things melt. And when clay melts almost completely, we call that vitrified. So it's basically converting something into a glass or glass-like substance. So think about the difference between a flower pot and a piece of like fine china. You guys have probably all handled a flower pot before, and you might even have one with a plant in it. And you know how like when you put a bunch of water in the flower pot, the outside of the pot gets damp, right? Like it's really porous and the water can kind of flow through the clay. So that clay is not vitrified. It has not been fired hot enough to the point where it's like fused together and become glass-like. Now, if you have ever used like a porcelain teacup or plate, that clay has been fired hot enough to where all the clay materials in there have fused together and become very close to glass. And the reason they're not glass is because there's a few other ingredients in there that keep it from being like really transparent. But you've probably all seen porcelain that's translucent, where light can shine through it. So basically the difference between clay and glass is just silica and flux. And so it's silica that's been able to melt because we've added a flux to it and added heat. And then a clay has alumina in it, and alumina keeps the glass from flowing and turns it into more of what we call ceramic material. So they're really, really close. Glass and ceramic are kindred spirits. So when we're thinking about a clay body or a glaze, there's three essential categories of the materials that are in it. Glass formers, and that is our silica. So really it's just a glass former. Like we typically are only using silica in our clay to create the glass. And it can be used in a raw form, but it's also present in a lot of the different materials that we have in the Glaze lab. So silica is in almost every material that we use. And so glass former is the first essential category. And then fluxes are our second essential category. And those are oxides. And I'll show you a list of different materials kind of organized by their categories. And the fluxes, those are materials that help things melt. So we have to mix a flux with silica to get it to melt and create a eutectic, which I'll talk about in a second what that is. But without fluxes, we would have to have way more powerful kilns to melt silica, because silica doesn't melt until it gets up to 3,110 degrees Fahrenheit, which is quite a bit hotter than cone 6 and quite a bit hotter than cone 10. So we have to add fluxes to it to get the silica to melt for us. Now, if we just added fluxes to silica, we would end up with like runny, melty material, kind of like when you melt ice and it just like turns into water and flows away. So in order to keep the glaze from running around and melting everywhere, we have to add a stabilizer. And what we use as a stabilizer is alumina. And so if you look, we have silica as a glass former and alumina as a stabilizer. Those are our two main ingredients in clay. So almost any clay that, or every clay that you would ever find or use is going to have a decent amount of silica and alumina already in it. And so you automatically pretty much have what the ingredients that you need just from grabbing a clay off the ground or out of the container in the glaze lab. And so this stabilizer alumina is primarily from the materials that we use. It's like part of the chemical makeup. And the alumina adds viscosity or slows down the flow and keeps the glaze like sitting on the side of our ceramic piece instead of flowing off into onto the shelf. And then as we were looking at our glaze recipe last class, we have these additives that are colorants, which are different oxides and stains, opacifiers, like if we want to make a clear glaze opaque so we can't see through it, there are different materials we can add to opacify. So there's this cool thing that happens with ceramics that is called a eutectic system. And some of you may have heard of the gallery here in town called Eutectic Gallery, and this is where the name comes from. So eutectic is a cool phenomenon that happens that allows us to make ceramic things. The definition of a eutectic is a mixture of materials that has a lower melting point than any of its parts. What the hell does that mean? It means that silica melts at 3,110 degrees Fahrenheit, but cone 6 is only 2,194 degrees Fahrenheit. How do we get this silica to melt? Well, when we add a flux to the silica, it lowers the melting point of the silica, and what we call that is a eutectic system. So it's essentially the lowest melting point of two materials when they're blended together, and then we add heat to them. So it's a cool thing that happens, and it's essentially a chemical reaction that happens between these two materials when heat is added that allows for the melting to happen at a lower temperature. I guess an example of that would be if you had ice and you wanted to melt the ice without raising the temperature above 32 degrees. If you add salt, there's a chemical reaction that happens. The salt mixes with the water and it can no longer be solid, and it'll actually melt at a lower temperature. So that's a way to kind of maybe visualize it. We have those three categories of glass former, stabilizer, and flux. And this is like a really general kind of ratio of how much of those materials are in a glaze. So in a typical glaze, it's gonna be 50 to 75% silica. So a lot of it is silica, but then we need to have some flux and some stabilizer. And so just in general, like, 12 to 30% of the materials in your glaze should be fluxes, and 10 to 20% should be stabilizers. So when we're looking at different glazes, you guys have probably seen matte or satin glazes, glossy glazes. Those surfaces are a expression of the amount of silica and alumina to flux, the ratios between those things. And so here we can see this appropriate proportion of silica alumina to flux gives you glossy, and that's like within this realm. But if we add like way more flux than we typically would have, then things don't melt properly and you'll get a satin or matte glaze. And the same thing happens on the other end of the spectrum. Like if you don't have enough flux, then the silica and alumina can't melt, and then it's more of a matte glaze. And so matte or satin glazes most of the time are just mean glazes where everything hasn't melted enough. And so there's still like powdery material in there that's creating a textured surface. So a glossy glaze means that all those ingredients are melting together really, really well. Some things to think about with your glaze testing is your clay body. So the clay body that you choose will affect the glaze and the way that the glaze looks like, or the way that the glaze looks. So if you have like a white background, that will be a bright white background for your glaze to show the color a lot more vibrantly. Darker clays, glazes will appear much darker on them. It's because most glazes that we use are not completely 100% opaque. They have some translucency, and so having a dark background will influence their color expression. Another issue with your clay body is what we call glaze fit, and that's the way that the glaze sits on and interacts with the surface of the ceramic piece. So some issues with glaze fit happen when the glaze shrinks at a different rate than the clay. So with all these materials, as we heat them up, they go through some expansion and contraction, and that heating up and cooling down. And depending on how much things melt and their different chemical compositions, they will have different rates of shrinkage. And so oftentimes we will see some what we call glaze defects or issues. Something that you guys have probably all seen are what's called crazing, where you get like little cracks, little lines in the glaze. We call that crazing. Shivering is a really big issue. It's where the glaze actually pops off of the surface. And the difference between those is that with crazing, what has happened is that your glaze is shrinking a little bit more than the clay or than the ceramic. And so what actually happens is that the ceramic is like a little bigger than the glaze is, essentially. So the glaze is like pulling away from itself because it's trying to fit on the surface there. It's similar to like if you were to go to a lake bed and it used to be mud, and the mud is dried and there's all these cracks. It's because that mud is shrinking more than the ground underneath of it, and so it's like pulling away from itself and revealing all these cracks between. Shivering is the opposite issue. It's where your ceramic object underneath the glaze is shrinking more. So the glaze is bigger than the ceramic object, and so it's actually doesn't have anywhere to go because it can't shrink more, and it just like has to break and pop off of the surface. So those are two possible like glaze fit issues that we might encounter when we're testing. We have these different categories of our materials, right? So we have our silica, which is our glass former. And then those come from, typically we're finding that from clay. So when we look at a glaze recipe, the clay is the glass former. Typically has a lot of silica in it, but we can also add pure silica to our glaze. Some of you may have found glaze recipes that say flint in them, or they say silica, or they say quartz. All three of those things are the same. So flint equals silica equals quartz. So those are all the same thing in in ceramic speak. And we can add just straight silica to a glaze or clay recipe to increase the amount of silica that's in it, but often we're finding it in these other materials. Our main sources for flux are these feldspars, and these are all different types of feldspars. But then I also talked about frits, and frits are just, they're like manufactured materials. So all these materials here, these are different singular materials that are found out in the world. They, at a certain mine where they're digging and extracting materials from the earth, they may find like a vein of a material in the ground that is this specific feldspar that some company who owns the mine named it Menspar 200. And it's just a mineral that's being dug up out of the ground and packaged for our use in ceramics. And so all these different things are just different materials that are found in the ground and are processed and packaged up for us to use. Now frits are a combination of these different things. You could actually think of a frit as a glaze. Somebody made like a clear glaze and then they fired it so it was a glass, and then they pulverized it into a powder and put it in a bag and sold it to us so we could put it in our glazes. And so they're like processed materials that are really consistent in the different frits. They all have different numbers and they melt at different temperatures, so we can kind of like choose a certain frit for a certain example. These are just different examples of feldspars. And so feldspars will have potassium, alumina, silica, oxygen, or maybe they have sodium, alumina, silica, oxygen, or calcium. Okay, so if we're looking at this recipe here, and we're trying to figure out like, what are all these things? I have a sheet that I shared with you that's part of the information that I posted under this assignment in Canvas. And it's, there's actually two of them. One is really basic that I'll show you right here. This is one of the forms that I gave you. And it shows here, your basic components. You've got your flux, which is your melting agent. You got your alumina, which is your viscosity agent. You got your silica, which is your glass former. And then there's these oxides and carbonates that are additives. So when you're looking at your recipe, cross-reference with these forms that kind of tell you what they do. So you can start to get a sense of what they actually do. So that'll be your first step, is just kind of go through your recipes and say like, okay, I have spodumene. What is spodumene? So you can go through this list until you find spodumene. Oh, it's right here. It is a flux, cone 5 flux, but it'll also reduce viscosity, so it makes a glaze more fluid, which is what we associate with fluxing, and it can do some other things here. So spodumene is a flux. Let's put that on our sheet here when we're assigning. So we'll write flux, and then OM for ball clay. So what OM stands for is old mine. So this is this ball clay is a really plastic clay that they dig up in the old mine number 4 in Kentucky. And so it is a clay. It says it in its name right there. And so when we're assigning its category here, when we think about clays, we know that it has alumina and silica. So it's both a glass former and a stabilizer. And if we go to Glaze, so click on materials and type in OM4. When we go there, we get OM4 ball clay. And when we click on that, it gives us tons of information. But one of the things I'm looking for is like, what is it made of? So if we look here, it shows us that it has all these different things in it. So it has our silica and our alumina, but it also has all these other things that are fluxes. So when we go back to our information here, it's also a flux. So from a clay, we get all three things. We know that frits are fluxes now. We know that silica is a glass former. What's dolomite? I don't know, but it's got a great name. Dolomite is a high fired flux and promotes a longer and lower firing range in the clay. So it's a flux too. And then we have these two additives, so titanium dioxide and rutile. And if we look those up on our sheet, titanium oxide is an opacifier. Now there's a dioxide, so we can see if we can find a titanium dioxide somewhere. Sometimes they're just listed. There's like a million different ways that these things are named. So we'll go with the titanium oxide and assume that it's close to it. And it's an opacifier. So we'll put opacifier there. And then let's find what rutile is. Rutile. It's a colorant, I think. So if we look at the top of that, oxides, metallic oxides, and carbonates. So that's a colorant. So if you guys spend some time with your recipes and do this exercise where you look up each individual recipe or individual ingredient and then just type out like where it fits within the different categories, then that'll help you start to understand what the different ingredients are doing in your glaze. So that's our main thing that we're going to do in terms of the glaze research, is to just go through your different recipes and look up the different ingredients that are in there, and use this chart. There's another chart that I gave you that has a ton more information. And so here you can see way more information, but it's a similar situation where it's going to tell you what the chemical makeup is, what their potential uses and stuff are here. So I think that's probably way more information than you all needed or wanted about Glaze at this moment. But I'm trying to just like give you a understanding of like what's happening underneath the hood there. So what I want you to do with your glaze recipes that you collected is to go through them, list all the different ingredients, and find out like what category they fall under. And then if you have questions about certain things, write those questions down, so then when we meet in person next week, we can sit down individually with all of your recipes and talk about what the ingredients are and what they do, and where to find them in the Glaze lab and stuff like that.